Hello, everybody. Welcome to the virtual keynote speech today. And today's speaker is Laurie McElroy. McElroy is a professor of Smart Resilient City in the Department of Architecture at the University of Strathclyde and is the immediate past president of IBPSA. Laurie is an engineer with a background spanning the application of simulation in environmental engineering, architecture, and sustainable design, and has been active in energy and environment field for over 25 years, both in practice and research, working in the private and public sectors. Laurie has focused her career on changing the way construction professionals do business, and in particular by embedding building performance simulation in design practice. This includes delivery of 3 government-funded state-of-art academic industry collaboration programs and dissemination of this work internationally. She is a regular advisor to Scottish government on joining up delivery of low carbon energy policy and building standard. Let's welcome Professor McElroy. Professor, you can start now.
Thank you. Okay, I'll just start my presentation. Okay, hopefully this will come up. My presentation will come up in a moment. I'd like to say hello to everyone. I'm not sure what your time zones are, so I won't say good morning, but it's afternoon here. And I know it's evening in China. So hello, everyone, and thank you very much for your kind introduction, Professor Xu. I would like to express my pleasure and thanks to the organisers of Building Simulation 2023 for inviting me to speak today. I'm sorry that I'm unable to be with you all in person, but I am glad to be able to participate virtually, something that only a few years ago would have been much more of a challenge than it is today. IBPSA's purpose is to bring together those researching and working in the simulation field and to act as the voice of building performance simulation internationally. And in that context, I'd like to offer some thoughts regarding the role of building simulation in improving our built environment now and in the future. I will also touch on some of the related challenges and opportunities that I think might lie ahead. We have a great opportunity to make a difference, but a lot has happened in the last 3 or 4 years. Many things have changed. People's attitudes are different. The world has been through a lot. People are generally less trusting of experts, so we need to win their trust by working to understand their needs and expectations. As an illustration of the potential, I will finish my presentation with a case study of a recent European-funded project between researchers in 3 different IBPSA affiliates. This was led by the University of Graz in Austria, and involved my group at the University of Strathclyde in Scotland and the Technical University of Delft in the Netherlands. And my hope is to demonstrate that this could be done on a universal worldwide basis. Taking on board recent events from the pandemic to the climate emergency to the energy crisis many of us are facing, we have an opportunity to support new ways of thinking about the impact of the built environment on our health and the health of the planet. We have to learn from the countries that did things well during the pandemic and to apply that learning going forward. Governments in most countries are already reviewing how they approach things. I know they are in my own country, and particularly in relation to indoor air quality and the relationships and the quality of the spaces between buildings and access to safe outdoor spaces. But what will be the impact of these changes, for example, on energy use and climate emissions as we transition towards net zero? How do we make sure that we bring people along with us on the journey? And we also need to be better prepared should anything like this happen again. It's both complex and complicated. Simulation can make an important contribution by testing new ideas about how buildings and places work. Ours is a field with great potential, but even now we're a young industry with much to learn. But the time is right. The pandemic has created a new acceptance of digital approaches to working, and the climate emergency has provided an imperative. We could be on the cusp of a new era for our chosen field, but this needs to be seen in a wider context, combining modelling with a better understanding of how buildings actually work and what people expect from them. Many of the problems we face require local as well as global solutions, which is particularly relevant from an IBPSA perspective, as we are an organisation with shared goals and a global reach, but operating through an affiliate structure which focuses on addressing issues at national and local levels. In a way we could not have anticipated, over the past 3 years, we have all focused on developing new ways of working and digital communication, for example, through virtual learning, digital and hybrid working, and digital communication. In addition, we have developed a way of sharing information through shared data repositories. And this has led to an unexpected opportunity to break down some of the traditional barriers to participation in construction, be these cultural, gender-based, or physical. And this is an area that I will speak about later. And it's not just us who have extended our digital skills. This extends from the youngest in society to the oldest generations, which will have an impact on the designed for, as well as the designers of our built environment. Everyone understands digital learning much better than they used to. And unexpectedly, increased restrictions on travel and physical distancing in some ways has brought us closer together and also created opportunities for international collaborations to address problems that were seen as insurmountable in the past. In our rush to get back to normal, some of the gains we made are already disappearing, but hopefully we can capture and nurture some of the best ideas that came out of the pandemic and the global shutdown and use these to transform ways of working and living on a more permanent basis. It may not be the same thing to attend a conference digitally, but at least it offers an opportunity that didn't exist before. Although I was rather jealous when one of my colleagues sent an image of the cruise that he happened to be on 5 minutes before I started this presentation. Following the COVID-19 pandemic, new restrictions and challenges are arising in building and urban design. Cities need to change and adapt, as will populations. And things that we took for granted have already changed, from negotiating our high streets to inhabiting artificially conditioned spaces. More rapidly than ever, the role of urban design and architecture in defining cities is evolving as we move from an age of physical infrastructure to a digital age. New approaches to planning are needed to help us adapt our existing infrastructures to make them fit for purpose and more resilient to future disruption. But how do we adapt these environments to ensure the best environmental quality and to support human well-being while addressing wider climate and societal concerns? Throughout this journey, data will be vital, but to what end? For some, there is a perception that technology will provide the answers, But for others, the role of data will be to support a much more people-centred approach. And as I understand the changing landscape, there are three things which are coming together. There is already mass movement of people across the planet, and there are also climate-related issues. These problems include the need to make cities more resilient to weather events and other environmental challenges. And the role of new technologies is emerging in terms of supporting the cities of the future. These are all areas that are high on government agendas worldwide. Underpinning this are health and well-being, an ageing population, and living well in older age. As we establish a new normal, we will need to move quickly as the pressures are mounting across the planet. We also need to completely rethink how we design and use our internal environments. The pandemic has revealed new challenges for simulation in delivering safe indoor environments in terms of air movement, air quality, and the role of temperature and humidity in the spread of such viruses, particularly in crowded spaces such as theatres, cinemas, and sports venues, but also in the ordinary buildings that we thought we knew how to design, like schools and housing. We also need to consider safety when participating in otherwise healthy pursuits outdoors. And what was once the domain of specialists, such as ventilation systems for clean rooms or managing people flows in a space, may become a standard requirement. We need to be ready, but we also need to be honest and more conscious than ever about the limitations of technologies like simulation. We need to be conscious of the difference between knowing how to apply tools and interpreting the results. We need to work with experts in other fields, and we need to do much more listening to the expectations of users of buildings and places. And finally, we need to use that knowledge to develop the new tools, skills, and practices needed to support the industry in meeting the challenges ahead. For example, in the long term, should we be reimagining cities based on social distancing? How would we do this as populations grow and people migrate to urban areas? Will we need schools with more outdoor classrooms to keep our children safe? Can we apply new ideas to old places as well as new? And as a result of recent events, citizens worldwide are suddenly much more aware of the need for healthy environments and buildings, and the importance of wellness and safety has overtaken any notion of comfort. The quality of the spaces and neighbourhoods we inhabit have suddenly and rightly been propelled into the spotlight. But how do we reshape our thinking before sliding back into our old ways? We know that those with access to high-quality outdoor spaces were generally less adversely affected by COVID-19, particularly in terms of their mental health. But how do we achieve better indoor and outdoor environmental quality while addressing global emissions targets and providing access to clean, healthy outdoor spaces for all of our citizens? We also have an energy crisis to deal with. Soaring energy prices worldwide, and people are already making difficult choices about how to spend their money. And we also have a need to drive down fossil fuel use. It's no longer a question of the experts having all the answers. There is now a worldwide community of experts, grown out of a lived experience, with a heightened sense of the need for healthy environments and buildings, and what this should look like. One thing is clear. Our clients will be less passive than in the past, and the importance of health and well-being have overtaken many of the more technical aspects of measuring performance. Now, we talk about smart cities as if this was a new concept, but we shouldn't lose sight of the fact that cities have always been smart. They evolve and adapt as technology evolves and will continue to do so. What we need to do is to harness technology and use it to our advantage, from renewable energy opportunities in cities, to working with citizens to gather and exploit data on how we want to use our cities going forward, to making better use of big data. While digital technologies such as the Internet of Things, artificial intelligence, and machine learning, simulation, and digital twinning all have a role to play, they can't address cultural, people-centered matters such as public engagement, inclusivity, understanding what makes a good place, and the impact that this has on people's lives. And in this respect, while big data can help us to explore trends, small data based on observation is just as valuable in other ways. And this slide here is one that shows children from an inner city area near where I live in Glasgow being taken out to explore the outdoors and getting up close with things that they don't have any opportunity to do near where they live. But in a way, they are also information gathering. From a built environment perspective, the construction industry needs to work with governments and businesses across the world to provide safe, healthy places for people to live and work in. And with social, political, and economically driven mass migration driving people from rural to urban locations and across continents, the existing infrastructure is already struggling to cope. So the governments need to address these issues quicker, cheaper, and better than ever before. All of this presents opportunities for innovation in terms of how governments design new legislation and guidance, and in research and industry in terms of rethinking how we protect what we have, how we reduce emissions, how we manage scarce resources, how we protect people, how we future-proof infrastructure, and how we make all places resilient to man-made and natural stresses. To meet the challenges ahead, we need to embrace new approaches and tools. We will have to engage and work with innovative, creative people. And there is evidence emerging that combining traditional and digital methods could help designers and governments to get things right first time. For example, in terms of integrating new technologies and ideas into construction, energy and infrastructure projects, and reimagining traditional methods, planning healthier, well-connected environments with rather than for people. Even those firmly wedded to the worlds of simulation and digital solutions are now acknowledging the importance of understanding human behaviour rather than expecting behaviour change. So while the role of simulation will continue to grow, we have a responsibility to make sure that we use it appropriately and that we give good advice. And IBPSA is progressing this agenda through our education programme, summer schools and special projects by engaging with others on the front line, from building users to building managers and the construction industry generally. With developments in artificial intelligence and machine learning and behaviour modelling, our tools and models have become much more sophisticated. This has supported a move from purely theoretical and technical or science-based solutions, which were really what was happening when I started in this field, to softer, more human-centred approaches. We're not quite there yet, but by combining simulation with traditional methods such as environmental performance monitoring, post-occupancy evaluation, and occupant feedback, we're already developing, enhancing, and improving our simulation tools to better represent real human behaviour based on how people actually use buildings rather than how we would like them to use them. This is particularly relevant to the millions of existing buildings that need to be retrofitted in the next 25 years. And so in future, I can see us working much more closely with policymakers, sociologists, and health professionals. This also provides new opportunities to collaborate more widely with the politicians and social scientists who now find themselves needing to answer questions that they were never asked before. From an academic perspective, the right data can support research and the development of good digital solutions, but the wrong data will be negatively disruptive. The use of technology to support people rather than to monitor their behaviour is also vital, but this is difficult to balance. And as we try to shape the cities of the future, observations through non-invasive wearable sensors by willing participants are already gathering data on how we use space internally and externally. But as a result of the pandemic and other recent world events, citizens around the world are wary of intrusion and surveillance. We like to be in control, not controlled. And this is a sensitive area, as many of the technologies that can support our governments to help us, we are inherently suspicious of. Although the approach varied from country to country, for most of us, as I've already said, the pandemic resulted in a general switch to digital working, learning, socialising, and even exercising. This has had a positive effect and negative impacts, but one thing is clear. In terms of inclusion, remote participation has made it easier for some traditionally excluded groups to play a more active role. But it has also effectively eliminated many of the barriers that prevented their participation in the past. For example, in the construction industry in particular, there have always been cultural, language, physical, and particularly gender-based barriers to equality and inclusivity in the workplace. In my view, we didn't fully grasp the recent opportunity, we only touched on the possibilities. But this could still provide a springboard for far greater equality, diversity, and inclusion in construction. It's important that we retain what we've learned and don't slip backwards into the old ways of doing things. The second part of my presentation is going to introduce a project that was born out of the pandemic and which we believe points the way to a new approach to digital learning in building performance and resilience. COVID-19 in 2020 forced universities to completely rethink their teaching concepts in order to allow safe, remote teaching of students off campus. One of the challenges faced by institutions during this time has been to ensure that the quality of the learning experience remains high and that students are able to engage and thrive in this new and predominantly digital environment. Through IBPSA, a small group who had long promoted a computational approach to built environment performance evaluation in education, resolved to use the restrictions on travel during the pandemic as an opportunity to test how far we could push virtual distance learning. We developed a proposal and were successful in securing funding to do just that. Inadvertently, we were also able to explore how enforced inability to be physically present in a workplace might point the way to resolving ongoing barriers to participation in construction generally. My own university, the University of Strathclyde, has strategic partnerships with both the Technical University of Delft and the Technical University of Graz. And against a background of the pandemic, a group of researchers associated with these three universities and IBPSA agreed to collaborate on a call from the Erasmus Student Exchange Programme. For those who are not aware, Erasmus is a European programme that traditionally supports student exchange between participating countries, allowing students to spend a semester or more in a partner university. but during the pandemic, this was not possible. About 6 months after the global lockdown, I was approached by Christina Hopfe from the Technical University of Graz, who was leading on an initiative to develop a digital Erasmus project. Christina has been researching the teaching of simulation in higher education for many years and is also a champion of equality and diversity. Equality, diversity and inclusion is a core value of IBPSA, and it's therefore appropriate that the project lead for this project and the co-investor leads in each country were female. Despite the number of women working in the field of building performance appraisal and the construction industry, it's still unusual for projects to be led by women. This team was led by Christina Hopfe from the Technical University of Graz as principal investigator, with myself and Eleonora Brambilla as leads in Scotland and the Netherlands, respectively. Combining our team's skills in building performance simulation and indoor environmental monitoring, with others, we developed a model to explore whether or not virtual learning could deliver more equal opportunities for inclusion and diversity. As building performance assessment researchers, we all had experience of operating in a virtual environment. But could this be pushed to develop a virtual exchange programme where students could collaborate across 3 countries without ever leaving home? And how rich could this experience be? The project was titled Digital Erasmus, a roadmap to using building performance simulation to achieve resilient design. And it responds to this context by seeking to transform the learning experience of students in built environment disciplines through remote learning. The objective was to develop a dynamic experiential approach aimed at maximising student engagement and learning opportunities in a digital and transnational environment that encompasses and supports diversity and equality and promotes the inclusion and participation of underrepresented groups. To achieve this, we developed a safe yet challenging learning environment that exposed students to new ways of thinking and working, one which provided a framework for like-minded people to get to know each other, to collaborate and to learn with and from each other, independently of their geographical location. The programme is now complete and served as an example to test the possibilities, and I'll now outline the essence and objectives. One exciting aspect was that this approach might offer an opportunity to participate for students who were unable or unlikely to travel to participate overseas for cultural, socio-economic, health or other reasons, even under normal circumstances. So actually it went beyond our original expectations. So while the starting point was COVID travel restrictions, the ultimate goal was became much broader. In addition to building an inclusive higher education experience and promoting international collaboration, the focus of the learning aspect of the project was to support students in acquiring and developing new skills and new competencies that would address environmental and climate goals. Inclusivity is a vital dimension in higher education, especially in engineering and construction-related fields, which are heavily male-dominated. Our project was designed to create a more inclusive learning environment by focusing on a digital approach to design, and at the same time testing how a lack of opportunity for face-to-face interaction might change perspectives. The premise was that the virtual classroom is inherently less intimidating and imposes fewer barriers than conventional learning methods, as it provides a higher degree of anonymity and privacy that would otherwise exist. Furthermore, the use of an online digital format allows flexibility in relation to learning times, therefore allowing those with other responsibilities to take part. The Erasmus scheme already promotes internationalism in higher education by supporting travel to encourage academic and cultural learning. But during COVID-19 travel restrictions, we wanted to explore just how rich an alternative digital experience could be. This was a huge departure from the norm, as traditionally student mobility has been placed centre stage within the programme. However, through a well-designed online learning programme, we proposed that many of the benefits of internationalism could be maintained through a virtual learning environment. We argued that the proposed digital approach could also address the social inequity aspects of such schemes, whereby not all students have the necessary resources to support a period of study abroad. As such, we hope to create a transnational learning experience in a globally inclusive manner. Each of our universities focused on a different aspect. TU Delft on building performance monitoring and particularly on daylight simulation and indoor climate. TU Graz on energy monitoring and indoor air quality. And Strathclyde on using monitored indoor environmental condition monitoring to calibrate simulation models. Each institution offered a virtual test bed or case, which became a case study, linked to monitored data from real buildings gathered by low-cost smart sensors. This allowed students to work in international teams, 2 virtual and 1 on location in each country, exploring real buildings and testing the impact of their design decisions in relation to key performance indicators, such as energy use and indoor air quality. In addition to developing a digital Erasmus programme to address continuing COVID restrictions on student mobility, we sought to do all of the things listed on this slide. We sought to provide a learning platform to allow students to complete a digital learning cycle in building performance appraisal and resilience. We sought to offer a working environment in which students from multicultural and underrepresented backgrounds could thrive, and one which enhanced diversity, equality, and inclusion outcomes. And we sought to challenge students to work in interdisciplinary and transnational teams to improve their social communication and interpersonal skills. Despite the fact that significant effort has been directed at making building performance simulation inherent in architectural and engineering practice, evidence shows that there's still a long way to go before this goal will be achieved. And while it's relatively easy to train an architect or engineer to generate simulation predictions with any research-based or commercial tool, an understanding of the theory of the thermodynamics underpins the application of simulation. So while it's possible through experiential learning to gain deeper understanding of the subject, it remains challenging even for experienced users to produce results that are truly transferable to the built environment. Users often place too much faith in their simulation tools without a deeper understanding of their inherent uncertainties and the associated risks of misinterpretation. Furthermore, the user is often the greatest source of uncertainty in this process. To make the connection between simulation and reality clearer, one of the strategies adopted was to couple simulation and measurement assignments in order to encourage students to see things from the user perspective and to build insights into other people's lives and day-to-day challenging. So inclusion was inherent in the whole process, both internally and externally to the project. It was also felt that teaching could benefit from the use of data collected digitally via automatic remote monitoring using smart sensors uploaded and shared via cloud services. And this aligns well with the direction of travel of how a smart built environment is perceived and described. This approach was found to be beneficial in helping students to become familiar with uncertainty and risk in decision-making when building models and then when dealing with the practicalities of the construction sector and real building occupants. The intention was that students in all 3 locations would be able to access the same data, with the advantage for all of having one team on site to speak to occupants, probe anomalies and questions or inconsistencies on behalf of the wider group. So far, we've developed 3 modules, 1 in each country, and have put structures in place in each institution to allow students to join from home and overseas. The Strathclyde model involved an introduction to the principles of building performance simulation and energy systems. Throughout COVID, the University of Strathclyde has still managed to work closely with the Scottish and UK governments on indoor air quality and energy performance improvements in homes. This work provided the test bed for our project. A local housing provider was exploring a number of approaches to improving the performance of existing homes, including comparing deep retrofit and whole house ventilation with more traditional approaches to balance user needs and emissions targets in order to arrive at workable, practical solutions. Environmental and energy monitoring systems were fitted in the buildings, including indoor temperature sensors, CO2 sensors, relative humidity sensors, temperature and heat flux sensors, and there was also an on-site weather station. Students worked alongside expert practitioners and researchers, comparing modelled and measured performance of housing with user feedback on perceptions of indoor environmental quality. The work included calibration of building models with recorded and monitored data. The project has been highly successful and has empowered participants by providing access to a new and broad range of skills with people with complementary skills, thus helping to eliminate barriers to both study and practice, but also adding strength and rigour to existing disciplines. With the end of the COVID pandemic, it's apparent that in-class teaching is once again becoming the priority. Students are now back in attendance with the possibility to conduct measurements and make site visits in person. In order to maintain the flavour of the Pan-European Digital Erasmus year under these new circumstances, we're looking at new ways of incorporating hybrid teaching modes that will allow the students who want to continue collaborating between different partner countries without losing the richness and diversity provided by the Erasmus experience. Although based only in Austria, the Netherlands and Scotland for now, we're already exploring the potential to expand this through the network of IBPSA. And to this end, we're developing ideas to support the continuation of the project through IBPSA, perhaps by linking the project with the IBPSA Academy and Education Committee, and/or as a potential future IBPSA project, thus allowing participation opportunities for students from all over the world. I've been a champion of the routine use of simulation in design and construction for over 25 years, spending much of my career transferring simulation tools from research into design practice. And so I'm excited to see the new possibilities emerging at a practical level for many of the things I've been advocating for a long time now. When I started out in this field, some of the things that we now take for granted were not even on our radar. I used simulation without any visual interface, relying on numbers and commas and hoping for the best when I sent my model off to the mainframe computer, which was in another building. And in those days, even simple simulations took all night to run. So having a 6-second delay between slides and text, it was really not as huge a challenge for me as it once was. We've come a very long way technically, but we still have some cultural barriers to address. I believe that the things that I've discussed present enormous opportunities for all of us here and for those coming into and through our field. We may choose to go back to an absolute normal in terms of resuming our ability to travel, but this project offers new and exciting opportunities to support and nurture young talent, wherever it is and however it presents itself. Thank you.